Okay, everybody, good morning. Hope you guys are doing well. We've got a little bit of lecture to get through, mostly calculations, but you've got a few definitions. So we're going to start with definitions. We're going to talk about the chemical mole, molar mass, and mole conversions today. So what you are going to need is obviously your notes, your calculator, and a periodic table is going to be necessary. Okay, if I can get this going here. Okay, so what is the mole? Okay, so a mole is considered to be what we call a counting number, or it is a number that is used to group things. Okay, we don't use it, you guys don't use it on a regular basis because we don't normally use the mole to group really large things. We like to use the mole to group things that are really small, like atoms, ions, molecules, compounds, okay? Some examples of counting numbers or grouping numbers that you guys are familiar with are the dozen. A dozen is equal to 12, or baker's dozen is equal to 13. A pair is equal to 2. A ream is equal to 500. So all of these are grouping numbers, and they're used to group a certain number of things. Mole is the same thing, okay? Mole is a grouping number, a counting number, and it groups a whole lot of things. Not 12, not 2, not 5. It's a lot. So an actual definition, a true definition for the mole is the number of carbon atoms in 12.01 grams of the isotope carbon-12. So if I add 12.01 grams of carbon-12, and I was to count how many atoms made that up, it would be the mole, okay? And the mole is equal to 6.022 times 10 to the 23rd. So if I massed out 12.01 grams of carbon atoms, okay, the amount of carbon atoms I would have is 1 mole, which equals 6.022 times 10 to the 23rd. This number is a number that a scientist came up with. Avogadro is his last name. He's got like 4 different names on top of that. But if you can remember Avogadro, then you're going to be in good shape. So Avogadro's number is literally 6.022 times 10 to the 23rd. So Avogadro is a scientist who worked with gases, and he did several different tests with gases at certain volumes and certain pressures. And he determined that 1 mole of a substance is equal to this many particles. So they named Avogadro's number after Avogadro. So notice I have items behind the 6.022 times 10 to the 23rd. So just like I could have a dozen shoes, I could have a dozen donuts, I could have a dozen eggs, I could have a dozen Snickers, I could have a pair of shoes, I could have a pair of gloves, I could have a pair of socks, okay? The items that are paired up change, okay? Same thing with the mole, okay? So the items that you're going to be labeling things right here is going to be like atoms or molecules or compounds, usually atoms or molecules, okay? So 1 mole is equal to this many items. This number has another name, and it is called Avogadro's number. So 1 mole is equal to Avogadro's number. Anytime we're labeling something, a mole, we just drop the E and just add and just stick MOL on there. It's a real time saver, obviously, dropping that E, but anytime we're labeling something moles, it's MOL. As you can see right here, it says this video link is on Google Classroom. Be sure to watch the video. So this video right here is on Google Classroom, and I expect for you guys to watch it. It gives you some really good examples and another good explanation of what the mole is. So please make sure you watch it if the sub doesn't show this to you in class. Okay, so you don't have to write this down, but hopefully this gets you the point, okay? 1 mole of water molecules is 6.022 times 10 to the 23rd water molecules. 1 mole of sugar, 6.022 times 10 to the 23rd sugar molecules. 1 mole of cheeseburgers, which would be